Okay, this is a high-level agenda for the presentation today, and let's quickly go through it. Some of the slides, information you may already know. Until 4 years ago, right? Not many people really aware of what is the semiconductor industry is. In a way, kind of COVID helped us. The two things that happened during the COVID time, right? Everybody started working from home. Colleges, schools, they started doing remote training, and people, suddenly the demand for laptops have gone up, and even tablets. That's okay. I think this is okay. Okay, okay. Is it better? Okay, sure. So people started, realizing what is the importance of semiconductors is, and also another thing, right? Especially the automotive industry, they got really hit badly. A lot of people started waiting for delivery of cars, and then people, why is it happening? And say, okay, this is all because of shortage of semiconductor chips, and there is a disruption in the supply chain. So basically today, anything you touch, this one or this one here, the laptop there, the lights you see, the projector, everything is, center of it is driven by semiconductors. Anything you touch, the car you drive, the watch you wear. So it's become a center, basically the main chief component for anything we do today, any application. So if you look at how are these chips designed and made, this gives you a very high level view of how the chips are designed and manufactured, all the way to production. So basically, once you design, understand the product requirement, then you put together an architecture for it. What kind of CPU you use in it, what kind of memory you use in it, and every chip needs a interface basically to get the data in and out. And these are all called, high-speed interfaces. I think my last company was focused on building these IPs. And then, typically, these interfaces. For a TV, HDMI is a popular interface. Every cell phone has a USB interface, and like every laptop today. Similarly, inside you, there is something called PCIe. So these are all, interfaces. You put together all these things, you come up with an architecture. After that, you also, put together all these blocks and you verify it, and you, at the same time, every chip, every CPU needs a software on top of it, firmware. And you also, have to co-design that in parallel. And after that, sometimes you can go put all this design on an FPGA simulation, FPGA platform and simulate it. Then you actually do the physical design for it. And so this is once you do the physical design, this physical design is targeted towards a particular foundry. So if you want to design this chip and get it manufactured at TSMC or Global Foundries or some other fab, this is where the actual design gets converted into a format that goes into this foundry and gets manufactured. So this is also one of the crucial steps. And personally, my background is physical design. I actually made my career doing layouts for the chips. That's how I started my career. And after that, you get the wafers done from the fab, and then you package. Each wafer will have sometimes thousands and hundreds of chips in them. So you have to cut that wafer into individual chips and package them and test them before you send them to manufacturing either a cell phone or a set-top box or a laptop. Okay, this is a very high level recapture of the design and manufacturing flow. Wait, wait. So I won't talk too much about this. When I started my career, the transistor size, again, some of the faculty, when we talk about the transistor size, it's the channel length. It used to be 1 micron. This was in 1990 when I first joined my first job in IDT. Today we are talking about 3 nanometer. I mean, the 3 nanometer is already in production at TSMC. So you can imagine how fast the technology has been changing, how it's been evolving. Okay. And now we are packing billions of transistors. If you take a very advanced, we have people from AMD here and Xilinx. So you take one of their leading GPU chip or CPU chip, it will be having billions of transistors in it, literally. So I won't talk too much about into this. This is more of a marketing data. Now semiconductor industry used to trail behind the automotive industry very closely. Now they're saying it is going to be $1 trillion market worldwide, $1 trillion business worldwide by 2030. And it is such a huge market, and what kind of role India playing in this market? Today it's very insignificant. Other than the design talent we have. Today I think they're saying like some 1.5 lakh chip design engineers in India, and most of them are working for multinationals. I mean, even my colleagues here, either they're working for AMD, they're working for Qualcomm or somewhere. We're helping these multinational companies put together this design chips. But do we own the IP? No, we don't. Do we manufacture those chips in India? No. We, in the end of the day, we simply buy these chips back from these companies to manufacture our devices in India. So our contribution is quite insignificant today. I think that is where the Modi's government kind of put together this $10 billion package to promote manufacturing and also product and IP companies out of India. We're going to talk about it a little later. So this is again other interesting thing, right? When the semiconductors first started getting into demand, this was in 80s. Most of the industry that was driving the demand for chips was PCs, mostly computers, PCs and computers. Later on in 90s and the networking, right? The internet came up, and every company they were like connecting all these computers through the internet, and then the homes Wi-Fi routers, these things they started. The demand for semiconductors started driven by the networking and communications. Then later on, the mobile phone market, and that's where the demand really started growing exponentially. I think now even today the mobile phone market is kind of maturing a little bit, and now the new growth is coming from automotive and artificial intelligence. These are the new two growth areas that's really driving the demand for semiconductors. So again, artificial intelligence, right? People have been talking about it quite a bit. Recently, we hosted a AI seminar in Hyderabad. This is again, one of my brainchilds as I was working part of Indian Electronics and Semiconductor Association. So we started conducting seminars in AI that talking about both hardware and software requirements and also growth opportunities in AI. So this is again a huge growth opportunity both for software, firmware professionals getting into writing applications. At the same time, people building hardware that meant for specific AI applications. So AI again, people talking about edge and cloud and all that stuff. I won't get into those details. It's a completely different subject, but again, it's a huge market opportunity, career opportunity for people get into in the next 5 to foreseeable future. Again, all these things, buzzwords you see in mobile, industrial, smart, automotive, even medical. Nowadays, every medical procedure people do, the more and more advanced, equipment coming up. Even for diagnostics, that's become a serious market for, advanced equipment that use a lot of semiconductors, image recognition. It's a huge, huge opportunity for semiconductor and AI applications. So, what is the world doing, and what exactly specifically India is doing today? And naturally, the government of India, they haven't been focusing on this for a while. And if you look at India had its first semiconductor fab in Punjab, near Chandigarh. It's called Mohali Semiconductor Complex Limited. So this was established in 1984 or 85, somewhere around that. And I was very fortunate to do a 3-month internship there. That's how I really got introduced to semiconductor industry. From there, I went to US and did my masters. So this fab was set up even before the TSMC fab was set up in Taiwan. But unfortunately, this is a government-owned fab. They didn't have a strategy to commercialize it. They didn't want to, continuously. This is like semiconductor fab. It's like a treadmill. You have to continuously keep upgrading your technology. You have to, open it basically to customers all over the world. You have to run it like a business. But this was running more like a government public sector, and more to look for some chips that can go into local applications. So it really never took off, and we never really stayed in in competition with the industry or the worldwide market. So I think that's when the government realized, because another problem is every chip today we consume in India, it's all imported, and we have to pay for these chips in dollars. So it's a huge burden on the government. I mean, to commit so much foreign currency to import electronics, import semiconductors. So there is no, I mean, so we want to develop some self-reliance in there. So that's the reason, the government of India, thanks to Modi's government, in the last 10 years, they started focusing on this. They put together this $10 billion package. Even before that, they were actually focusing on mobile phone manufacturing. Today, I think most of you may not know that most of the iPhone 15s or 14s you're buying, they're manufactured in India today. Apple has 2 manufacturing plants in India, producing the top 2, 3 models in India today and exporting to other countries from here. Similarly, Samsung, and they have probably 3 to 4 factories somewhere near Noida, Delhi, and they're building and assembling some of the top models in India today. So in the last 5, 6 years, very quietly, India became the second largest mobile phone manufacturer already. But the problem is every chip that's going in there is imported, not a single chip produced in India. So that's what we're trying to address today. Okay, and that is the reason they put together this package. They are inviting fabs, they are inviting OSAT. OSAT again stands for Outsourced Semiconductor Assembly and Test. They also have another name for it. It's called ATMP. I think it's Automated Test Assembly, Test, Mark, and package or something like that. Okay, so this is basically you manufacture the wafers, and that is called semiconductor foundry. You package the chips, that's called OSAT. Okay, so these are the 2 things the government is trying to establish in India. They have a huge budget. They're traveling all over the world to invite companies, and so far the success has been that good. But ultimately it will happen. So we are trying to set up one of the first OSATs in Hyderabad, and I think we're making some good progress. Hopefully we can announce the project and start the construction of the factory soon. Similarly, even US government, they also put together some $52 billion. See, for 20 years, right? I mean, actually, when I moved to Silicon Valley, we used to have at least 20, 30 semiconductor fabs there. They all shut down. Everything moved to Taiwan, China, all that stuff. They thought they can simply design the chips and get them manufactured outside. Suddenly they realized, man, we need to have the fabs back. We lost the control on this technology. So they also put together a huge budget, $52 billion, trying to bring the fabs back. But end of the day, today, you have all these fabs, you have all these ecosystems, but you need the design talent. So most of the design talent in US, kind of, they're getting into the retirement mode. All my colleagues, there are not many US kids, American kids, they won't, I mean, not that many of them getting into semiconductor field. Most of them get into, business, economic, finance, and I mean, even most of my kids, they didn't want to do semiconductor. They wanted to do something else. So this is, I mean, if you look at worldwide, the largest student community is from India today, especially the kind of engineering colleges we built, and this is where the opportunity for India to make, to play a very very important role, and this is where we need to train and produce more semiconductor engineers, whether it's design, manufacturing, testing. I'm going to talk about what kind of jobs really out there today. So I'll kind of skip this, get to the real meat here. So if you look at the job market, right, end of the day, you're not giving a degree. I mean, degree is okay, good, it's a piece of paper. But you are training your students to go perform a particular role in a semiconductor company. So you need to understand what kind of jobs out there and how your syllabus and your training programs, your labs, preparing them to take up these jobs. So you need to, this is where the collaboration between the industry and your faculty, your curriculum, your, infrastructure, tools you use, EDA tools. This is where we need to collaborate, work together. Okay. So this is a very high level. On the semiconductor industry side, the design side, I mean, people just just sit down and do the architecture design. Similarly, the just do the RTL design and verification. So these are the different type of job titles there. I mean, generally not, very few times you see an engineer trying to do the whole thing himself. These are all specialized jobs. There are people designing a PLL analog, for the rest of their lives. Okay. So this is where it is, and I think, you need to kind of tweak your curriculum for that. So I'm going to skip this slide as well, and talking about number of job, how it is, and this is kind of immaterial here, and I'll kind of fast forward a little bit. How many jobs out there, employment, what AT&T, Foundry. But one thing today, there are not that many jobs in the manufacturing side. I mean, there are EMS jobs out there, but not many jobs out there in the fabs or these things. But trust me, you still need to start working on it today. There are fabs and ATMPs and other things going to happen in India. That time you cannot suddenly find them. But even in US, for example, they're building these new foundries. They don't have enough process engineers. So this could be an opportunity for these kids. Maybe they do a bachelor's here in manufacturing, go do an MTech there, finally get a H1 there and find a job there. So this can be, I mean, initially they can go and work out of US and other places where the fabs are happening. Again, somebody else earlier said Prime Minister Modi's responses, they put 100 crores, they're funding the colleges, they're providing the tools, all that stuff. And we talked about Micron Technologies setting up a huge OSAT in Gujarat. Similarly, LAM Technologies, and hopefully you'll see one of ASIP's name here pretty soon, setting up our own, OSAT here. As I said, manufacturing jobs are going to pick up in India. So you need to probably start thinking about it, whether you need to have a separate, a few courses focused. I mean, there is IIT, I know IIT Hyderabad is already focused on a packaging course, semiconductor chip packaging course. Similarly, IISc in Bangalore, they're also, I think, looking at offering some packaging courses. So I think you should be since you're already in the top 100, maybe pick up some of these courses towards manufacturing. So with that, I know, I took probably a lot more time than what's allocated to me. I'll conclude here. The opportunity is huge, and the students, they have to learn more about the industry, opportunities, and they need to take the relevant coursework and build strong fundamentals. So that is most important. It's not like just taking a course and getting a piece of paper. you need to really, this semiconductor industry, you need to understand the basics. Basics have to be strong. There's no, you know, and hands-on expertise. That is a really good thing. I think I heard you have synopsis and mentor tools, and but you need mentoring to use those tools, and you need to have some projects, where people can go and actually use those tools, create some IP or create some small chips out of it, and validate them. Okay. Otherwise, people just go open the tool, click, click, click without knowing what they're doing. It's not going to help in any ways. Okay. And this is a very difficult field. That's what I'm any student trying to get in there, this is not a 9 to 5 job. It needs a lot of hard work. Okay. You have to work hard. My guys can go watch for it.